Hello everyone, this is Nilesh here once again. In the last session, we had introduction to the .NET platform. We seen how to write Hello World application using Visual Studio 2026 Community Edition. I also shown you how you can write the program without Visual Studio and compile it from the command line. We compared the compilation and execution of the .NET application with respect to C++ and Java compilation and execution process. We've seen that the compilation and execution process with more or less difference remains same for all .NET compatible languages. Of course, this discussion was at the very beginner or introductory level. Then we seen the .NET Framework SDK, and we also talked about the different editions of Visual Studio. I also told you about the important terminologies related to the CLR. These terminologies are Common Language Specification, Common Type System, and Just-in-Time Compiler. We also had a very short idea about the memory management and garbage collection. Now that you have understood some basic background of .NET, now it's time to deep dive into these concepts. Today, we will actually try to understand the Hello World application first. I will explain you the code briefly. Then I will also show you how to create a class library and access it in a console application. Once we understood this, then we can understand more about .NET assembly, because .NET assembly can be .exe as well as .dll. So we will see the differences and how exactly the .NET assembly is structured internally. I will also try to show you the content of it. Then we will talk about how exactly the .NET framework application is executed. Purposefully, we will restrict ourselves to .NET framework in this session, and then in upcoming sessions, we will talk about the .NET Core execution. We will also have a look at .NET framework versions so far. Now, let us begin with the process. The very first thing is about Hello World application that we wrote yesterday. To understand the Hello World application, let me take you to the yesterday's code. And in this particular code, we talked about something called as a using system at the beginning. Let me tell you in short what exactly it is. Here, system is a namespace. Here, system is a namespace. Namespace is a concept of a C# which is borrowed from C++. And the primary purpose of the namespace is the logical organization of the code. We will discuss about namespaces in more detail later on, but for time being, you understand that system is a predefined namespace. And whenever we create any new project in the Visual Studio, by default, the project name is used as your namespace. So yesterday, our project name was Hello World, and inside that, Hello World namespace is created. So this namespace is basically the collection of all your types like classes, structures, delegates, interfaces, and so on and so forth. Then inside this Hello World namespace, we return something called as a class program. Currently, we mark it as internal. The internal means it is accessible only in current assembly. You will understand it better when we will go for the ClassLibrary application. But this is my class program. And this class program has got one static void main method. As you can note that the main M is capital, which is not similar to the C++ or Java. Why display method is static? Because this particular main method, which is also called as the entry point of your .NET application, is called by the CLR, and CLR want to call it without creating object of your class. That is the reason the method is static. The method return type is void because our method is not returning anything to the CLR, and this method is taking argument string args array, which is a command line arguments. Now this command line arguments, when I run the program on command line, for example, if my program is hello world.exe, then I may pass some additional argument on command line, and these arguments will be collected as an array inside this string args. Later, we will have one demonstration about the same. Now, inside this, we are using the console class. The console class is part of system namespace. That is the reason the using system is written on the top. And then this console class has got a static write line method. That is the reason we are not creating an object of console class. We are directly writing console.writeLine. And then we pass the message hello world, which is showing me the message when the program is executed, just like this. Great. Now that you have understanding of this, we can go ahead. And today, as I said, we will begin with creating a proper solution for the application. So how we will have the solution of the application? Let us create a new project. And in this new project, I will not go for a console application. Instead, we will talk about something called as a blank solution. Let me quickly search a solution from this, and I'm creating a blank solution. This solution, we will have the set of projects related to each other. And what solution is this? Let us call this particular solution as a math solution. A very simple, very beginner friendly example I'm trying to create. Now, in this particular solution, I will be having two different projects. The first project will talk about the reusable classes, that is nothing but the class library, and then another front-end application, which is console-based application, which will be actually using these classes. How? Let us get started. Let me right-click this and add a new project. Now, in this new project, I want to select something called as a library project. So we can refer to something called as a class library project inside this. Done. Currently, as I said that I'm restricting myself to Windows, and I want to create a class library using .NET framework only for the Windows. I can click on the next. The library name that I want to write is a math library. Again, .NET framework version 4.8.1 selected, and this math library project will be created inside our math solution. So inside our solution, this is nothing but my first project. And in this project, let me rename this. I call it as, let's say, my math class. Okay. As I told you earlier, the namespace name is by default same as your project name. Inside this, I want to write some very basic level method like public integer add method. I can pass x and y as argument, and we can simply return x plus y. I can also write maybe one more method, let's say subtract method. And yes, you can continue writing multiple methods over here. This is a very simple example where a simple math library is created. When I build this, if I build this, what exactly get created? The library is set of reusable classes. Library is not a kind of a self-executable. So if you try to see this inside File Explorer, you will find that inside bin, inside debug, no executable is created. Instead of executable, you can see a simple DLL file is created. Only a DLL file, you can check it over there, only a DLL file. And please note that these DLL files are not self-executable. You cannot execute the DLL. If you try to run a DLL, it will straight away give you the error. So how exactly this set of reusable classes are to be used? We can import this library into any other application and we can run it from there. So let us complete this solution by adding one more project. So let me say add new project. And now we will go for our classic console application. Again, I want to go with the .NET Framework application. I click on the next, and this is referred as math application. I click on create. Now inside this application, what exactly I want to do? I want to call those methods, add method, subtract method over here. But these methods are part of another library. The question is how this library is accessible into my class. That is done by adding reference of it. So you can right click on the math application and add the reference. While adding a reference, there are several ways the reference can be added. Let me quickly select the projects from the same solution. I'm selecting a project from the same solution, that is mathlib project, and I click on OK. Now, moment you see OK, apart from other predefined library references, you also find the mathlib reference over here. And now you can access that mymath class from there. How you can access mymath class from there? That can be done just like predefined namespace. We can say using mathlib. Great. And once using mathlib is done, I'm ready to access my math object over here. Now I can simply make a call to the obj.add. I can pass the values and this will give me the result. I can print the result. Let's say the result, addition result, I can say is equal to res1. That's good. If you want, I can print it one more time. Let's say I will call it first subtraction. So res2 is equal to obj.subtract and maybe same values I'm passing once again, where I'm saying that subtract result. Subtract result, maybe I want to print this res2 over here. What is another way apart from the string concatenation? I can quickly use another method like 0 and then I will write res2. If you worked on C kind of language, there's like a printf, and in printf like a %d, %f, %s. So we can use different format specifier. Now similar concept, you can use it in C# as well. But instead of using kind of %d over here, we simply mention the argument position. If you have kind of multiple arguments to be passed over here, let's say second argument, maybe third argument, and so on and so forth, you can continue to use 0, 1, 2, and so on and so forth. That can be done. Now, for time being, let me write this much. Let me build the application and let me try to run the application. So let me say build the application. build. And how do you run it? I hope you remember, you can say Control F5. Let me say Control F5 and you will see some error. And the error very clearly mentions that the project with output type of class library cannot be started directly. Now, this is very important. I told you the library is a DLL file. DLL file can never execute on its own. If you want to use it, you need to import it into some other project and you need to run that project. But since our first project was class library, it was set as a default project and that cannot be run. So what I need to do next, just right click onto this and set this as a startup project. Now my math app is a startup project. I can say Control F5 and you can run this. I guess that is wonderful. If you just take a look at this, I will show you what exactly happened when we added the reference. When we added the reference, definitely the information about the library, the metadata about the classes is imported in this project. But not only that, when we build that application, you will be able to see that the whole mathlib DLL is copied from that debug folder to math app debug folder, and which is there in a mathapp.exe, which is built from this project. Now, when I'm running mathapp.exe from here, which is also referring to the mymath class written into another library, you will find that this library get automatically loaded. Let me try to elaborate it again at the very basic level stuff. So at the very beginner level stuff, I can tell you that when you try to execute this, maybe by saying Control F5, or you can even double click and run this. When you try to run this, what exactly happened? This particular mathapp.exe is loaded into the RAM for the execution. It is loaded into the RAM for the execution, and for this mathapp to run, there is a kind of a process created. Maybe operating system process is created over here. Now, once that process is created, mathapp library, mathapp class is coming over here and it is started executing. It also see that it needs my math class, which is part of the library. And in that case, this mathlib.dll is also loaded into the same process memory. So already math app process is created, and this mathlib is also loaded in the same process, and then they execute together as a single entity. Please note that this mathlib DLL is not limited to the math app class only. In future, you create some sort of a desktop application or some web application where you need this addition subtraction once again. At that time also, you can just reuse the same library again and again. Correct? So a quick difference or quick understanding of what is .exe and what is .dll. A quick understanding of .exe and .dll is here. So your exe is self-executable. When you double click it, it will execute on its own. It will have a separate operating system process created. And then what is .dll? The DLL is a library of the classes, reusable classes. It is not self-executable. It is referred as a dependent executable, because for execution, it depends on another process. It is loaded in the calling process memory when its classes are accessed in that process. I hope this has given you a bit idea about what is exe and what is DLL. Now that you have understood this, what is common in this exe and DLL? I will say that what is common in exe and DLL, in case of .NET, both your exe file and both your DLL file, both of them, they are called as a assemblies. They are called as a .NET assemblies. And they share the similar structure. They share the common structure. What is the common structure of the assembly file, whether it is exe, whether it is DLL? So every assembly file, we have something, multiple sections. The first section, you can call it as a PE header or as a portable executable header. If you are on the Windows platform, then any C application, C++ application, any executable file, you will always find that the PE header is there. The PE is executable file format of the Windows. So on Windows, for every executable, irrespective of the technology, it is having a PE header. On the similar line, for the .NET application also, we have PE header. Then second thing it contains is a manifest. What is manifest? So manifest contains the information about the assembly. That what is the version of the assembly, what is name of the assembly, which company has developed this, what is the culture of the assembly, so what is the unique ID for that assembly. All this information is present into the manifest. If you want to take little more understanding of this manifest, you can go to any project, and under the project somewhere you should be able to see the file assemblyinfo.cs. This assemblyinfo.cs contains a typical information or metadata about the assembly. And this metadata of the assembly, which is available in every particular project, this particular one is getting stored inside the assembly manifest. Then there comes metadata, or which is also called as a type metadata. Now, whatever classes that you have written, let it be in your class library like MyMath class, or let it be in your console application, let's say math app class, program class. So whichever class that you have written, the class information, the class name, class base class, then its methods, its fields, the complete details are stored into the respective assemblies metadata. We will come to this metadata topic in more detail when we will discuss about something called as a reflection. Then comes the most important part, which you call it as a IL code or intermediate language code. So all the code which is written in C# is compiled by C# compiler into intermediate language code. So Microsoft initially called it as something called as MSIL, Microsoft Intermediate Language Code. And this MSIL code is converted into the native code by the CLR, to be specific, JIT inside the CLR. Apart from this, in your application, you might have some resources. Now, these resources can be some images, maybe some logos, some configuration files about your application, correct? So this is the similar structure available for both the type of assemblies. Let it be the executable, let it be the dynamic link library. But as I said that the main difference, the primary difference is the DLL are dependent executable and exe is nothing but the self-executable. You can double click it and you can run it. Now the next question that comes to the mind, that can we take a look at this IL code? Can we look at this manifest? Can we see this information? Well, for that, one really beautiful tool comes with your .NET Framework SDK. So when Visual Studio is installed, this tool is already installed. Let me take you to our developer studio, the developer PowerShell or developer command prompt. And let me go to the directory where we have these things, our exe and DLL present. The name of the tool is ILDASM. Stands for IL is intermediate language, DASM stands for disassembly. And I can then show you something, let's say for example, mathlib.dll. Let me run this. Wow. You see a very nice GUI which is showing you the information about the DLL. And what it contains is a manifest. This is nothing but your assemblies metadata. This assembly metadata is the whole information that you might have seen in assemblyinfo.cs file. And you can also see some unique ID given over there. It also have certain flags. It also have certain image information and so on and so forth. It is given over here. Great. You can also see the name of MS Core Lib. I guess I told you that MS Core Lib is nothing but your base class library. So inside my application, inside this library, it is internally referring to something called as a MS Core Lib that I can understand from here. Now, what we have is a math library. And inside this math library namespace, we have my math class. This my math class, you can see that .setor talks about constructor, which is a default constructor provided. And then we have written two methods, add and subtract. If you can note it very well, though we have written int over there, over here I can see int32. Means my C# int type is internally converted to the CTS type, CLR compatible type, that is nothing but int32. Okay, that's great. If you want to see the intermediate language code for any of this, you can just double click on this and you will be able to see something like a addition code over here. So this is doing addition of two numbers and returning some result. Something similar, you can look at the subtract also, where you are doing subtraction of two values. Of course, you need not to understand these IL level instructions in detail at this moment because we are primarily writing code into the C#. Now, for sake of knowledge, you may go ahead and explore it. Now, I've shown you the content of mathlib.dll. I can also show you the content of mathapp.exe. And mathapp.exe is having mathapp namespace. And inside that is a program class. Inside that, we have main method. And inside main method, we are calling this console.writeLine to print this result. And something similar, we are calling subtract also and printing that result also. You can take a look at the main over here is considered as entry point for my application. Now that you have seen what is assembly and what is the things inside that, I believe now it is good time I can explain you the execution of the Hello World program. So whatever Hello World program that we wrote yesterday, how exactly that Hello World program is executed. In order to understand that Hello World program execution better, I strongly recommend that we will go back and we will try to understand how exactly a simple C or C++ program is executed. Then we can also take a look at how a Java program is executed, and then you can appreciate how exactly the .NET program is executed. So there we go. This is about C++ program execution. As I said that in C++, we can create some .c, .cb file, we compile it, and we create .exe. This .exe has got multiple sections. Again, like if you're on Windows, then it is a PE header, then it is a text section containing the machine level code, read-only data section, and symbol table, which gives the information about your variables and functions. Now, this hello.exe is created by your compiler and linker and stored on the disk. When you try to run any program, you should keep in mind no program can run in the hard disk. So moment I try to run hello.exe, what happens? The operating system loader comes into picture and loader will load your program into the RAM. Now this program running in the RAM is referred as a process. The process is an operating system terminology and it is defined as program under execution. So you see the process is created in the RAM. What that process contains? It basically copies the section, text section, data section, arrow data section from the hard disk, and it also create the additional sections like stack section and heap section. I guess yesterday I talked about the stack-based execution. So stack-based execution, for every function activation record or stack frame is created when the function is called. It stores the local variable, and when the function is finished, then that stack frame is destroyed, all local variables are gone. And if you have a little background of C and C++, then you might have heard of malloc or new operator. Now this malloc or new operator allocate the memory dynamically. Where this dynamically allocated objects, dynamically allocated memory goes, this is where we have the heap section. So this is nothing but the process under execution. But inside the text section, the code that we have is the machine level code. So your operating system's only job is this machine level code, native code, as it is to be given to the CPU, and CPU will execute it instruction by instruction. This is how a typical C++ program is executed. Now, you will see that the Java program execution is a bit different. When you take a look at the Java execution process, let us recall that I write something, let's say myclass.java, and myclass.java, I give it to the Java compiler, Javac, and that will convert it into myclass.class. What this .class file contains? It also contains a class header. It contains the metadata, the type metadata, and it contains that intermediate language code of Java, which is called as bytecode. But do you know how exactly the Java applications are executed? Because you cannot double click on .class file and you cannot run it directly. So how to run that? To run that, we have Java space the package name .class name. That is a command that we mentioned. But by the way, what is this Java? This Java is nothing but Java application launcher, which is responsible for launching, which is responsible for starting the Java application. Do you know that this Java that we give it on Windows is basically a java.exe that comes with your JDK. And the java.exe is a Windows executable. So when you are trying to run a Java application, the first thing you are actually trying is nothing but java.exe as a Windows executable. And any Windows executable, it never runs in a hard disk. The operating system loader come into picture and it will load this Java into the RAM and it will create the process out of it. This process is for java.exe. It is a Windows OS created process. However, this particular code, that is bytecode, metadata, that is understandable not by the Windows operating system. It is understandable by the JVM. So your Java application launcher, something it does is it brings the JVM into the memory. But where the JVM is created, talking about example of Java 8, the JVM itself is implemented as a special file in the JRE, that is nothing but jvm.dll. This jvm.dll is installed with your Java runtime environment, JRE. It is the implementation of the JVM. And when your java.exe process is created, it loads this particular JVM into the Java process. Now I can say that, yes, JVM is ready. Now, once JVM is ready, JVM says that now I will take care of executing the myclass application, myclass program. And for doing that, it will load the myclass into the memory of the JVM. It will load it into the memory of the JVM. It will verify it. Then it will convert it into the native code. using JIT or interpreter, and then that native code will be given to the CPU. So the execution process of the JVM Java application I told you right now. Please make a note how exactly JVM starts, because many people do know how JVM internally works, but many people just forget how JVM come into picture. So I want to stress that point. I'm telling you once again that whenever you run Java space the name of the .class file, the java.exe itself is a Windows executable. This Windows executable, when you run, its process will be created. Your java.exe will be loaded in the RAM by your operating system loader, and the java.exe process is created. Now, this java.exe is a normal process, but this process is designed for launching the Java application. And that is the reason the very first thing it will try to do is to load the JVM. The JVM itself is implemented in jvm.dll, which is a part of your JRE. And then that jvm.dll is loaded in the Java process. Once JVM come into picture, rest everything will be handled by the JVM. Meaning by that given class will be loaded in the JVM memory. Something memory area like method area or few more details can be discussed. And then it is interpreted, that bytecode is then converted into the native code by the JIT or interpreter. And then that is further given to the CPU. This is how the Java program execution works. Now you are ready to talk about exactly .NET program execution. Now, how exactly the .NET application runs? I'm talking about the simple Hello World program. The simple Hello World program is helloworld.exe. Great. Which is nothing but a .NET assembly. And what it contains, just now I was talking about, it will have PE header, manifest, type metadata, IL, resources, and so on and so forth. And it is kept on the hard disk. When you double click on it, when you try to run it, your operating system loader will come into picture, and OS loader will consider it just like a Windows executable, and load it into the memory. It will consider it like a Windows executable because of the PE header. Correct? So the process is created, and that operating system process will have this exe, this assembly loaded. However, this particular assembly is not going to be understood by the operating system or CPU directly. So very first thing that you need is a CLR. How exactly CLR come into picture? Let me tell you that when you run any C++ kind of application, when the program is loaded in a memory, the very first thing it tries to execute some entry point function, which in turn make a call to the main function. Now over here also, this PE header contains address of some entry point. And you know what is entry point? That entry point over here is mscore.dll. mscore, let me tell you full form, Microsoft Component Object Runtime Execution Engine DLL. Is this a CLR? No, it is not the CLR, but it is your gateway to CLR. It is the one who is responsible for loading the CLR. So as soon as your application get into the RAM, whenever the exe is loaded, it will try to call mscore.dll, which will be loaded in the same process. And then that mscore.dll will internally calls the actual CLR. What is the actual CLR? The .NET 4 and onwards, the CLR is implemented as CLR.dll. This CLR.dll is very much part of your .NET framework. So this CLR.dll get loaded into your process. Now, as CLR come into picture, CLR is ready to execute the actual application. And to execute that actual application, the first thing it do is it will load MS-Corelib, the base class library. Once MS-Corelib is loaded, it will create something called as a application domain. What is application domain? Application domain, you can consider it as an isolated environment inside Windows process to run any .NET application. I repeat, the application domain is nothing but isolated environment created inside Windows process to execute the .NET application. This particular application domain or app domain, you call it as, is always created for every .NET framework application. And you can consider it like a sub-process inside the actual OS process. Now, inside this application domain, your rest of the assembly content will be loaded. And once they are loaded, then your CLR will begin the actual execution. Means the main component, that is JIT. JIT will try to convert it method by method from IL code into the native code. And then that native code will be fed to CPU. CPU will execute it the instruction by instruction. This is the whole process, how exactly the .NET application is executed. Let us quickly walk through it once again. So hello world.exe, which is assembly created on the disk. When you try to run the application, when you try to double click the application, the Windows operating system loader feel like it is a Windows executable due to its P header, and it will try to run it into the RAM. To run it into the RAM, it will create the Windows OS process and get that exe into the memory. However, this P header contains the address of the entry point. This address of the entry point is not the CLR itself, but it is MS-Core-EE.dll, Microsoft Component Object Runtime Execution Engine.dll. This is the gateway. This is a door to the CLR. So this MS-Core.dll is loaded first, and then that MS-Core.dll in turn loads the CLR. The CLR itself is implemented as CLR.dll from .NET 4 and onwards. The earlier version, the name of the DLL was different. Now this CLR.dll is loaded. The CLR is ready for executing the .NET application. To execute the .NET application, the very first thing it will do is it will start with MS-Corelib, which is a base class library. Then it will create something called as application domain, a secure isolated environment inside the Windows process to execute that. And after that, it will get the rest of the assembly contents into that app domain. Not only it will get the basic assembly, but if your assembly is referring to some other assemblies, like your math app referring to the math lab, then even those assemblies will get loaded over here. And now, as you have the IL code for all of them, then that IL code has to be converted into the native code, and that job is done by the JIT of your CLR. The conversion is done method by method. And then this native code is then given to the CPU, and CPU execute it at runtime, maybe instruction by instruction. This is the entire process, how exactly my .NET framework is working behind the scene to execute my any .NET application. Now, this was again not a very detailed explanation, but I believe being a beginner, you should understand this much about how exactly the .NET program is execution. I would just like to refer one book if someone is interested. There was one good book called as the CLR via C#. If you want to go into the depth of it, understanding the .NET framework and its execution, you should be referring that particular book. Anyway, now that you have understood the .NET framework and the basic things, let us wrap up by taking a look at the different .NET framework versions that we had. So which .NET framework versions are there? The .NET framework, as I said, that it was started way back in nearby year 2002. We had the first version of the .NET framework. That was, we can say that .NET framework version 1.0. And then soon, maybe in year 2003 or 2005, immediately we had the next version, .NET framework 2.0. Meanwhile, in between, the .NET framework 1.1 was also there. And after that, in year 2007, we have like revolutionary version of the .NET framework, and that was .NET framework 3.0, which comes with something new features like WPF, WCF, and so on. Then in year 2010, we had next version of .NET framework, that is 4.0, come up with like some new enhancement. The biggest enhancement was the DLR, Dynamic Language Runtime, so that the .NET can be also supported with the language with dynamic typing. And then somewhere in year 2019 directly, we had .NET framework version 4.8, which is officially the last version of the .NET framework technology. Because meanwhile, somewhere over here in year 2015, nearby 2015, the Microsoft started with something called as a .NET Core. .NET Core is a bit different platform, though it is having the similar philosophy as our .NET framework. This is designed specifically to work on all the platforms. Now, using .NET Core, we can write the applications on Windows, Linux, and even Mac operating system. I hope this gives you idea about .NET framework. In the upcoming class and all these next sessions, we will write all our applications using .NET Core only. I guess you find this session useful. Thank you very much for listening so patiently. See you in the next class. Thank you very much. Bye-bye.